Hello, like it was said, I'm Teresa McGrath, and I'd like to thank you in advance for your time and the opportunity to speak to you about our group and our recent invention, the Carbon Scout Meter, which was the Innovation Award winner last year. Western Australia's Gold Technology Group has been bridging the communication gap between university academics and industry professionals to advance Australia's gold and precious metals industry for over 30 years. This collaborative approach has enabled the group to successfully manage the internationally renowned Amira Gold Processing Technology Research Project, surviving 3 industry downturns in the past 3 decades. Currently, there are 14 industry sponsors for the Amira P420E project, including both gold producers and service companies. With a budget of roughly $5 million over the current 3-year project span, the Gold Technology Group maintains a staff of 12 individuals, including senior academics, research fellows such as myself, and former industry professionals who oversee R&D, consulting and commercial work, software development, and specialist training. Over the past 4.5 years that I've been involved with the Gold Technology Group, I've heard my mentor and former director of the group, Adjunct Professor Bill Staunton, state, to optimize a process, you have to be able to control it. But to control it, you first have to be able to measure it. It's through this connection to industry that the measure, control, optimize strategy was developed as a response to problem-solving the issues faced by our sponsoring industry colleagues, and thus influencing our scope of research. For example, we have recently designed and now are commercializing the Scout Carbon Meter, a tool which automates sampling of the carbon concentration in gold leach and adsorption circuits, producing regular and reliable measurements. This method is actually quite simple. It just automates what the operators are currently doing. It takes a pulp sample of known volume, filters it through a screen, and measures the height by a laser, converting it into a concentration. The information is then used to control the movement of carbon through the process at a rate determined by our SimCell modeling package, which has already been used in the industry for over 20 years by both our research group and the industry sponsors. The combination of better carbon measurements and improved process control by use of the Scout and SimCell allows for optimization of the process, leading to higher gold recoveries at lower operating costs. The Scout was trialed earlier this year at Sunrise Dam, an Anglo-Gold Ashanti gold mine in Western Australia. Not only was the site impressed by the accuracy of the measurements and the lack of operator attention required for routine maintenance, but they were quick to make suggestions as to how we could further improve the design. Thanks to this partnership, the second version of the Scout will include takeoff valves for slurry samples, and will operate at ground level, reducing requirements for the staff to work on top of the cyanidation tanks. Further modifications to the unit might also include pulp density, pH, and dissolved oxygen measurements, collection of composite samples, and possible collaboration with industry partners to provide cyanide management and control. Ultimately, we aim to create a package which can measure, control, and optimize the leach and carbon adsorption circuits of gold mines worldwide. Thank you.